Hi and welcome. I'm so excited to have everyone joining us today. I'm Lisa Gibbons. I'm the founder of Lisa's Care Connection, and on behalf of our entire team, welcome to this really exciting discussion courtesy of CIRM, the California Institute for Regenerative Medicine, and more specifically, students that they are funding through a lab at UCSF. So we have some gifted thinkers on board today. I know you're going to love it. Before we get into that, because I know we all care about seniors, and we all know that socialization is a thing that really provides meaningful protection against cognitive decline. Let me just put in a little plug and a share that we are hosting our senior prom. That's coming up on September 18th. So if you are in the kind of Hollywood, LA area, we're at Blush Banquet Hall in North Hollywood. This is an intergenerational event. We'd love for you to come dance and party with us. And if you can't do that, you can still participate by sending a senior to prom. You can sponsor a ticket, so someone in our community who may have never been to the big dance can come. So we'd love to answer more questions for you about that at the end of this presentation. I am a very big fan of the exciting and important work that CIRM has been doing, gosh, for the last 20 years. I was privileged to serve on the oversight committee for 5 of those years, which I found absolutely thrilling, both with my personal history of 2 generations of women with Alzheimer's disease and with our work at Lisa's Care Connection, where we support family caregivers who are facing Alzheimer's, other dementias, as well as chronic diseases. We are all in today to hear this presentation. We are especially grateful for these students who will be talking about breakthroughs in gene and cell therapy as it relates to Alzheimer's and other chronic diseases. They're calling it Tomorrow's Voices, Today's Medicine. And with that, I will let Dr. Brittany Pennington, director of the CIRM Compass program, take it from there. Thank you, Dr. Pennington.
Great. Thank you for that introduction. And thank you to Lisa's Care Connection and everybody calling in today. Today, when you hear from our students, you'll hear how we're all crucial players in bringing regenerative medicine to the clinic and making it accessible to the public. Us as scientists working hard in the lab, but you as the public, California residents who are calling in by supporting CIRM with your vote on the ballot. And for anyone else calling in across the country, just your awareness of what regenerative medicine is doing for the public. And so the CIRM Compass program is a training program sponsored by the California Institute for Regenerative Medicine. CIRM's goal is to bring innovative cell and gene therapies to the clinic. In other words, making regenerative medicine more accessible to the public. And one of the many ways they do that is by funding training programs like CIRM Compass to help prepare the next generation of scientists to enter this field ready for success and to bring the therapies to you faster. So the CIRM Compass program is a 2-year research internship at University of California, Santa Barbara, UCSB. These students joined in their junior year or their 3rd year of undergraduate studies. The CIRM Compass program has a hands-on research component, which you'll hear about today, a little bit about what their own research does, about how it could one day contribute to a therapy. They've also done outreach to local schools, middle schools, elementary schools, and high schools to prepare the next generation of scientists and get them excited about the opportunities available in the field to help recruit them here. But these students also recognize their responsibility as scientists to share their work with the public. And so thank you so much for giving us an opportunity to share not only just our science, but also breakthroughs in regenerative medicine happening in the field with you today. So how we'll start today is we'll have one of our students, Olivia Scalfani. She's a recently graduated senior from UCSB. She'll share her research on Alzheimer's disease using a very interesting model system and also current therapies that are in the pipeline to treat Alzheimer's. That'll be the meat of the presentation. But afterwards, we also want to let you know what else regenerative medicine is doing for the public. So we have 4 other students that will give mini talks, 5-minute talks on what we're doing in other disease sectors like osteoporosis, diabetes, and cancer. So with that, I will hand it over to the coordinators to go to the next talk. Did I freeze? did I freeze? Sorry. I'll hand it over to the coordinators to go to the next talk. How much of that was caught? Did I miss a lot?
Got it
Okay,
all. I think,
great.
Olivia, are you taking it from here?
Yes. Good morning, everyone. Okay. Imagine a future where we don't just slow down Alzheimer's disease, but actually reverse its debilitating effects. Today, I'm excited to share groundbreaking research that brings us closer to making this vision a reality. My name is Olivia Sclafani, and I am a recent graduate of UC Santa Barbara, involved in exciting research at the COSIC Lab, and I'm funded by CIRM, the California Institute for Regenerative Medicine. Our focus is on unraveling the complexities of Alzheimer's and related forms of dementia. My personal journey with Alzheimer's, having lost my grandmother and now witnessing my grandfather's struggle, drives my passion for the field. This connection fuels my commitment to advancing our understanding and treatment of this disease and to finding solutions that bring hope to families like mine. This is a human brain. On the left, we see a healthy brain. It's full with no gaps. The brain is made of neurons, which are cells that send messages, and each neuron has a long extension called an axon, like a wire that carries signal. And inside the neuron, a protein called tau helps hold the structure together, like scaffolding. In Alzheimer's disease, the brain starts to shrink. You can see holes and gaps. These are areas where neurons have died. Inside the neurons, tau becomes abnormal. Instead of helping, they form tangles that causes the neuron structure to collapse. This leads to the neuron breaking down and dying. At the same time, on the outside of the neuron, a different protein called amyloid beta
I'm
starts
so
to
sorry
build
to
up.
interrupt, Olivia.
Oh,
I'm so sorry. I
yeah.
think the mouse wasn't aligned
Oh,
over what we can see as. I'm so sorry to interrupt.
no, you're good. Thank you for telling me. Is this better if you see?
It's much better. Yeah. Are you on the Alzheimer's brain right now?
Yes,
On the
on
black
like
hole? Yes.
yeah, okay.
Perfect. Great.
Using
Do
the
you want to
laser
start
function
from?
helped.
Do you want to start from the Alzheimer's brain?
Sure, yeah,
Okay.
thank you.
Thank you.
Yeah. So in Alzheimer's disease, the brain starts to shrink. So here we could see holes and gaps. These are where neurons have died. Inside the neurons, tau protein becomes abnormal. Instead of helping, they form tangles that causes the neuron structure to collapse. This leads to the neuron breaking down and dying. At the same time, on the outside of the neurons, a different protein called amyloid beta starts to build up. It forms sticky plaques that block cell-to-cell communication. These tau tangles and amyloid plaques together damage the brain, leading to memory loss, confusion, and other symptoms of Alzheimer's. Right now, the treatments we have for Alzheimer's are mostly focused on managing symptoms, rather than addressing the root cause of the disease. Medications include drugs like cholinesterase inhibitors, as well as memantine. These medications are designed to support memory, thinking, and decision-making by helping the brain cells communicate better. For many patients, they can offer short-term improvement in cognitive or behavior symptoms, such as confusion or anxiety. However, while these medications may temporarily ease symptoms, they do not slow down the progression of the disease itself. Over time, Alzheimer's continues to damage the brain, and these drugs can only do so much. In addition to medications, doctors also recommend lifestyle changes. Staying physically active, eating a healthy diet, and engaging in activities that challenge the brain, like puzzles, reading, or social interactions, have all been shown to support overall brain health. These interventions may help delay symptom onset or improve the quality of life, especially when started early. There are also supportive therapies. These include things like occupational therapy, which can help patients stay independent by learning strategies to manage daily tasks more easily. There are also counseling and support services, which are essential for both patients and their families. While all these options are important and can help manage day-to-day life, it is also important to be clear about their limitations. None of the current treatments can stop or reverse the disease. They generally offer temporary relief, and as the disease progresses, their effectiveness tends to decline. In addition, some of these medications come with side effects. They can range from mild issues like nausea, fatigue, and dizziness to more serious concerns, such as abnormal heart rhythms or gastrointestinal problems. For patients already dealing with multiple health conditions, these side effects can make the treatment even more challenging. There's an urgent need for new, more effective treatments. We need therapies that go beyond just managing symptoms. We need treatments that actually target the disease's process itself. This means stopping or even reversing the damage being done inside the brain. Cell and gene therapies represent a groundbreaking shift in how we might treat Alzheimer's disease, going beyond simply managing symptoms to tackling the disease's underlying causes at a molecular level. These therapies act as precise tools designed to repair or replace the faulty components within our cells. Gene therapy involves making precise adjustments to the genes within your body's cells. Think of it like a software update for a smartphone or computer. Just as the software update fixes bugs or adds new features to improve the device's performance, gene therapy introduces genetic updates to your cells. This process can fix malfunctioning genes that are causing disease or add new genes to help protect against disease. By updating the genetic software in your cells, gene therapy aims to enhance the cell function and combat condition like Alzheimer's at their genetic root, preventing the disease from progressing and improving brain health. Gene therapy aims to fix biological problems by adding a healthy copy of the gene, repairing the faulty gene, or sometimes turning off a bad gene. Scientists use carriers called vectors that are specifically designed to deliver the healthy gene into the patient's cell. The new gene goes into the cell, into where the DNA lives. The cell then uses this healthy gene to produce the correct protein. The cell can then function properly, and the symptoms of the disease can improve or even be cured. Gene therapy fights Alzheimer's at its genetic root, fixing faulty DNA to restore healthy brain function. Stem cell therapy uses the remarkable ability of stem cells to become any cell type the body requires, and this includes neurons. In Alzheimer's disease, where neuronal networks are lost or damaged, transplanting healthy stem cells into the brain offers a way to rebuild those networks. Once in place, these cells can differentiate into new working neurons that can take over the function of their predecessors and help restore overall brain activity by enhancing cognitive skills and memory processing. When we pair stem cell approaches with other cutting-edge treatments, we may not only halt Alzheimer's progression, but may even reverse its debilitating effects. This represents a seismic shift in how we treat neurodegenerative disease, no longer merely managing symptoms, but actually regenerating the brain. The ultimate goal is to transform Alzheimer's from a relentlessly progressive illness into a controllable, treatable condition, giving millions of patients a chance at a richer, more independent life. Stem cell therapies regenerate damaged neurons, restoring lost brain function in Alzheimer's. Clinical trials are research studies that test new medical treatments like drugs, vaccines, or medical devices to make sure they're safe and effective for people. These trials help answer critical questions such as, does this treatment actually work? Is it better than the options we already have? And what side effects might it cause, and are they manageable? Every medication today, from Tylenol to cutting-edge cancer drugs, once went through a clinical trial. It's a rigorous, vital process designed to protect patients and make sure new treatments do what they're supposed to do. Clinical trials are typically conducted in a series of stages called phases. Phase 1 is the very first step in human testing. A small number of participants receive the treatment to check if it's safe, how the body responds, and what the right dosage might be. Phase 2 involves a larger group of people and asks a new question: does it work? Researchers measure how effective the treatment is while continuing to monitor safety. Phase 3 is much larger, often involving hundreds or even thousands of participants. Here, the new treatment is compared to existing standard treatments to see which performs better, and researchers monitor for any rare or serious side effects. And finally, phase 4 happens after the treatment has been approved and released to the public. Researchers continue to collect long-term safety data and assess how it performs in the real-world setting. Each phase is designed to be thorough and cautious, and the entire process can take many years. That's because when we're testing something new, we want to be sure that it's safe, effective, and reliable. It's also important to know that many clinical trials use a placebo group, a group of patients who receive a non-active treatment. This helps researchers compare outcomes and determine whether the new therapy is truly making a difference. Now, it's worth noting that not all clinical trials succeed. Many treatments show promise in the early lab tests, but don't work as expected in people. Still, these studies are essential. Even when a trial fails, it gives us valuable knowledge that can lead us towards better solutions. And clinical trials are a major investment. The entire process, from early lab research all the way to FDA approval, can cost over $1 billion. These costs cover patient care, lab testing, monitoring, and regulatory compliance and data analysis to ensure that the treatment is both safe and effective. It's through these carefully designed trials that we lay the foundation for breakthroughs of tomorrow. Now, let's take a closer look at one of the most promising gene therapy approaches currently being tested for Alzheimer's disease. This trial is being led by researchers at the University of California, San Diego, and it's supported by CIRM, the California Institute for Regenerative Medicine. This therapy focuses on a powerful protein called BDNF, short for brain-derived neurotrophic factor. Think of BDNF kind of like the brain's fertilizer. It helps the brain cells grow, survive, and connect with one another. It plays a critical role in learning and memory, especially in a region of the brain called the entorhinal cortex, which is one of the first areas to be affected by Alzheimer's. In healthy brains, BDNF helps keep neurons resilient and communication pathways strong. But in Alzheimer's, levels of BDNF can drop by as much as 70% in key memory areas. This loss contributes to the disconnection and cell death we see as the disease progresses. So, what if we could restore those levels? That's exactly what this trial aims to do. The researchers are using a modified harmless virus as a delivery tool. It's engineered to carry BDNF gene directly to the brain to produce more BDNF again. Now, getting the gene exactly to the right place is critical. That's where MRI guided neurosurgery comes in. The delivery is done with incredible precision using real-time imaging to guide the placement of the therapy. This trial is currently in phase 1, which means it's focusing on safety, but researchers are also collecting early data on whether it can improve memory or slow cognitive decline. What makes this approach so groundbreaking is that it not just tries to slow down the disease, it's aiming to restore the brain's own ability to rebuild those connections and maintain memory. While it's still early, the idea that we could one day revive neuronal networks and help people regain function is incredibly hopeful. For many families facing Alzheimer's, that kind of regenerative approach could change the course of the disease entirely, not just managing symptoms, but targeting the root problem. The second groundbreaking gene therapy I wanted to share today comes from Lexeo Therapeutics, and it's particularly exciting because it aims to tackle one of the most well-known problems and most potent forms of the genetic cause of Alzheimer's, ApoE4. There are several forms of ApoE, but one in particular, ApoE4, has been strongly linked to Alzheimer's. People who inherit just one copy of ApoE4 variant are at increased risk, but for approximately 2% of the population who inherit two copies, the risk skyrockets up to 10 to 15 times higher than the average for developing late onset Alzheimer's. It's currently the strongest known genetic risk factor for the disease. What makes this therapy from Lexeo so innovative is that it doesn't just try to slow down the damage caused by ApoE4, it tries to cancel it out. Instead of targeting symptoms, this approach introduces a protective version of the gene called ApoE2 into the brain. It has been shown to reduce the risk of Alzheimer's and help protect the brain from the kinds of damage typically triggered by the disease. To deliver this therapy, scientists use a specially engineered virus to carry the ApoE2 gene directly into the central nervous system. This is done through a single spinal cord fluid injection, and it allows the therapy to circulate throughout the brain and reach the neurons where it is needed to help combat those harmful plaque and tau tangles. In preclinical trials using mouse models of Alzheimer's, this therapy had remarkable effect. It reduced amyloid plaque buildup by over 2/3. The phase 1 and 2 clinical trial for this therapy was just completed in November 2024. And while we're currently waiting for the full results to be published, this trial primarily looked at safety, but also started to assess how well the treatment works in real patients. What's exciting about this approach is that it represents a true precision medicine strategy, targeting the root causes of the disease in people who are genetically predisposed. It's a personalized therapy that offers new hope for those who, until now, have had few options beyond managing symptoms. If successful, this could pave the way for a future where we prevent Alzheimer's before it starts, especially in high-risk individuals. It's one of the first attempts to directly address Alzheimer's genetic risk factor at their source. Beyond gene therapies, another exciting frontier in the fight against Alzheimer's involves stem cell-based treatments. These therapies don't just focus on changing your genes, instead they work by supporting the brain's natural ability to heal itself. One particularly promising candidate in this space is a therapy called Lomecel-B, developed by a company called Longeveron. This approach uses a type of adult stem cells called mesenchymal stem cells, or MSCs for short. These cells are naturally found in your bone marrow, fat, and other parts of the body, and they have two powerful abilities that make them valuable in Alzheimer's treatment. First, they can reduce harmful inflammation, which plays a major role in the progression of Alzheimer's. Chronic inflammation in the brain can damage neurons, disrupt communication between brain cells, and accelerate memory loss. Second, the MSCs may actually help regenerate or support brain damage by releasing healing signals that encourage repair and survival of existing neurons. What makes Lomecel's-B approach more remarkable is that these stem cells have a kind of built-in GPS. When injected just into the bloodstream, they can detect areas of damage or inflammation and migrate to those specific spots without needing to be surgically placed into the brain. Now, let's look at some of the early clinical findings. This graph shows the effect of different doses of Lomecel-B. In pink here, we see a group that received the highest dose, 100 million cells across 4 treatments. In blue, we see a group that received 25 million cells across 1 treatment. In lighter pink, we see a group that received 25 million cells across 4 treatments. And then in black here is the placebo group. And as you can see, there is a clear trend. The more cells and doses patients received, with this hot pink being the highest, the less brain volume that is lost over time. In Alzheimer's, shrinking brain volume is a marker of disease progression, so slowing this loss is a very positive sign. Just as important, the treatment was shown to be safe. There were no major side effects or health issues caused by the therapy. And even more encouraging, patients who received Lomecel-B showed a slower decline in memory and daily functioning compared to those who just got the placebo. In some groups, there were even statistically significant improvements in thinking ability and quality of life, which is a rare outcome in early Alzheimer's trials. This is still in early stage research, but it offers a new kind of hope, a therapy that doesn't just treat symptoms, but may actually help the brain protect and repair itself. Now, let's turn to one of the most exciting areas in Alzheimer's research, personalized medicine. This approach tailors treatment to each individual, and in this case, quite literally uses the patient's own cells as therapy. A company called Regeneration Biomedical is leading a trial that harnesses fat-derived stem cells, also known as adipose-derived stem cells, to treat Alzheimer's disease. It turns out that we all carry a powerful regenerative source right in our own bodies, adult stem cells, and fat tissue is one of the richest sources. Here's how it works. Doctors take a small sample of the patient's fat tissue, usually through a simple and minimally invasive procedure similar to a mini liposuction, and from that sample, they extract and purify stem cells, carefully removing other unwanted cell types. Then, using advanced sorting technology, the team selects for only the most potent stem cells, the ones that show the strongest anti-inflammatory, neuroprotective, and regenerative potential. This step ensures that each dose of the therapy is optimized for effectiveness. Next, instead of injecting them directly back into the bloodstream, these selected cells are delivered directly into the fluid spaces of the brain, known as the cerebral spinal fluid. This allows the stem cells to circulate through the brain and spinal cord, reaching the regions where damage is occurring. And what do these stem cells do once they're inside? They go to work on multiple fronts. They help clear toxic proteins like amyloid beta and tau, which are major drivers of memory loss and neurodegeneration in Alzheimer's. They calm harmful inflammation, which can otherwise accelerate brain damage. And they stimulate the brain's natural repair system, encouraging neurons to survive, form new connections, and communicate more effectively. The early results from this trial have been promising. Within just 12 weeks, 2/3 of patients showed cognitive improvement, meaning their memory, attention, or thinking ability got better, not just stabilized. There were measurable drops in Alzheimer's biomarkers, including amyloid and tau levels. And because these are the patient's own cells, there's virtually no risk of immune rejection, a major advantage over traditional cell therapies. This approach taps into the body's innate healing potential, customizing a treatment that's biologically matched to each person. While more research is still needed, this personalized stem cell therapy offers a hopeful glimpse into the future where we don't just treat Alzheimer's, we help the body fight back in a targeted, natural, and effective way. Now, I wanted to talk about my research as a Compass intern in a CIRM-funded program. I study a surprising animal that might help us better understand Alzheimer's disease, the 13-line ground squirrel. In Alzheimer's, one of the major hallmarks is the buildup of tau protein tangles inside the neuron. These tangles disrupt the cell's internal structure, block communication, and ultimately lead to cell death. In humans, once these tangles form, the brain can't clear them. They just continue to accumulate over time. But hibernating squirrels, like the 13-line ground squirrel, are different. During hibernation, their body temperature drops and the metabolism slows down. And they also develop the same tau tangles in their brain, just like what we see in Alzheimer's. But when they wake up, those tangles disappear and their brain returns to a normal, healthy state. Even more remarkably, they also regain neuroplasticity, the brain's ability to form new connections and reorganize itself. Neuroplasticity is essential for learning, memory, and recovery from injury. And in Alzheimer's, neuroplasticity declines over time. But these squirrels are able to recover and rebuild healthy brain networks after hibernation. By studying how they do this, we hope to uncover the natural mechanisms that could one day help the brain clear tau and restore function. So to explore this phenomenon, I've utilized stem cells derived from these squirrels to create neurons and miniature brain models called organoids. By simulating hibernation conditions, by cooling these organoids in the fridge, I observe an increase in tau tangles. Remarkably, when returning them to normal body temperature, these changes reversed, mirroring the squirrel's natural recovery process. My research aims to uncover the mechanism behind this reversible tau modification. Understanding how hibernating animals naturally manage tau proteins could provide insights into developing treatments that help the human brain clear tau tangles, potentially offering new avenues for Alzheimer's therapy. To grow brain-like organoids from squirrel stem cells, we use carefully timed media changes and supplements to guide the brain development in a dish. This is a timeline of an organoid process from day 0 to day 25 and beyond. I currently have organoids that are 9 months old, so they can survive for a very long time. And the white bars here just show the feeding schedule. And then the blue boxes here show the different supplements we add. So we begin with a nutrient-rich base that supports early cell growth, metabolism, and structure formation. And then as the organoids mature, we gradually change the media to better support brain development and function. And to help these stem cells become brain tissue, we have to add special ingredients that support neuronal development and prevent unwanted cell types from forming. And this step is important for modeling cortical development and understanding how neurons behave during hibernation. We start by placing squirrel stem cells, which grow as a colony in a flat dish in these U-shaped wells, which encourage aggregation. And they naturally come together and form these small spheres. And then over time, these spheres grow and organize into more complex 3D structures. Here you can see a visual progression from a flat colony all the way to a large spheroid. And this system gives us a window into brain development and allows us to study how neurons respond to stress, like hibernation and clear tau protein. So here is an image of a brain organoid at 50 days, captured using fluorescent staining to highlight different cell types. In blue here, where the cell is stained, it just shows the nuclei, which is the center of the cell. Green marks stem cells. Yellow highlights mature neurons. And then in red, we see the axons, which are those long extensions the neurons use to send signals. We also see these circular patterns. And these resemble early brain structures, showing that the organoid is organizing itself in a way that mimics real brain development. And this tells us that our squirrel organoids are forming the right types of brain cells in an organized way, which is an important step for studying how they clear tau protein during hibernation. And in this slide, we look more closely at the types of neurons forming in our brain organoids using fluorescent markers again. So in green here, we have a marker called TBR1, but this just tells us if we get these deep layer brain cells. It's the kind that form in the inner part of the cortex during early development. And seeing strong TBR1 staining means our organoids are making these early brain cells correctly. In yellow, again, is MAP2, which stains for the neurons, and it highlights that they are mature and have branches. And the widespread signal MAP2 shows that many neurons have formed and are starting to make connections. We also check for a marker called CUX1 in red, which usually appears in the upper layer neurons that develop later. And we didn't see this marker yet, which suggests that our organoids haven't fully developed those upper layer cells yet, at least not by this stage. But together, this shows that our organoids are forming key types of early brain neurons and beginning to build networks. But they may still need more time or conditions to fully mimic all the layers of the cortex. So to test how the brain cell's activity changes during hibernation, we create a special cooling setup to mimic what happens when the squirrels go into hibernation. I place the squirrel brain organoids into a temperature-controlled water bath and slowly cool them down to 4 degrees Celsius, about the temperature of a refrigerator. I held them there for about 4 hours and then slowly warmed them back up to body temperature. This process matches what happens during real hibernation in the squirrels. Next, I use a special microscope and a glowing marker called GCamp that lights up when the neurons are active in white. This lets us watch the neurons firing in real time. This slide shows 3 short videos from the same group of neurons. So on the left here is before cooling. You can see that there is a lot of glowing happening and firing within the neurons. In the middle, during cold exposure, the activity almost completely shuts down. So here we don't see any flashing, which is indicating that the neurons are sending signals to each other. But then on the right here, after warming them back up, the neurons become even more active than before. So each video here is 5 minutes long, but sped up. And one thing I noticed was that individual neurons can go silent during cooling and then bounce back even stronger after rewarming. This means that the organoids can temporarily pause their brain activity, just like in real hibernation, and then fully recover. So here we see one example of that. We can see the neuron faintly flashing here before hibernation, but during hibernation, after these 4 hours, it stops flashing and is silent. And then after rewarming the media, we can see it start flashing again, even more stronger. So these results show that our squirrel brain organoids don't just look like real brain tissue, they act like it too. They respond to cold stress and recover with strong brain activity, giving us a powerful model to study both hibernation and how tau is cleared from the brain during this process. Next, I'll use this model to study how the brain clears tau during recovery and what we can learn from these squirrels to help protect people from Alzheimer's. My research and countless clinical trials are possible through CIRM. CIRM, the California Institute for Regenerative Medicine, is the world's largest institution dedicated to turning stem cell research into real cures. Created in 2004 by California voters through Proposition 71 and renewed in 2020 by Proposition 14, It invests $3.6 billion in taxpayer funding to accelerate breakthrough treatments and has been vital in making many clinical trials today possible. Thank you all for your attention today, and for those of you who live in California for supporting this research as a California voter. As we've seen, the journey towards finding effective treatments for Alzheimer's is both promising and challenging. Each step we take in gene and cell therapy research brings us closer to a future where Alzheimer's is no longer an inevitable decline, but a treatable condition. Now, you might wonder, how can I help or get involved? Here are a few impactful ways. Advocate for more research funding. Reach out to your representatives to support increased funding for Alzheimer's research. Public support is crucial for advancing these groundbreaking therapies from the laboratory to the clinic. Participate in clinical trials. If you or a loved one is affected by Alzheimer's, consider participating in a clinical trial. This is a powerful way to contribute to the development of new therapies and to gain access to cutting-edge treatments that you can find by going to clinicaltrials.gov. Educate each other. Share what you've learned today with friends, families, and colleagues. Awareness and understanding are key to destigmatizing the disease and garnering more support for research. Support Alzheimer's organizations. Many organizations are dedicated to Alzheimer's research and patient support. Consider volunteering to help advance their work. And stay informed. The field of Alzheimer's research is evolving rapidly. Keeping informed about new studies, trials, and advancements can help you make educated decisions about care and support advocacy for policy change. Your involvement can make a significant difference. Whether it's through advocacy, participating in research, or sharing knowledge, each action you take supports the collective effort to combat Alzheimer's. Let's work together to change the course of this disease and to offer hope to millions around the world. And with that, I'd like to say thank you, specifically to Dr. Andrew Longini, who is my direct mentor in lab and who has taught me everything I know and has helped me with this project, and Dr. Ken Kosick, who is the head PI of the lab, and the whole Kosick lab for all their knowledge and support throughout this project. And then specifically to CIRM and the Compass program, who have funded this research and made it all possible, which has been headed by Dr. Brittany Pennington, who is here today, and Dr. Dennis Clegg. They have been amazing resources, and none of this would be possible without them. And I would finally like to thank you all for being here today and for learning more about the science and steps we can take together to fight Alzheimer's, because your support truly makes a difference. Thank you.
Thank you so much, Olivia, for sharing. At this moment, we don't have any questions so far. So if the next presenter would like to go ahead and present, feel free to do so.
Amy, do you want to fire up your presentation?
Sure.
All right, well, first off, thank you so much, everyone, for being here today. When you break your bone as a kid, you probably remember it by the fun cast you get after and how many signatures you could collect on it. But as we get older, fractures start to become a risky fact of life. Osteoporosis is the most common bone disease worldwide, and it's often called a silent disease because we can't feel it happening. My mom and her friends all just went through menopause, and it's something that I worry for her constantly. However, today, I'm excited to share the new research being done to help treat this condition. I'm Amy Zhu from the CIRM Lab at UCSB, and I'm also a CIRM Compass trainee. As a CIRM Compass trainee, our goal is to help people return to their daily lives through the power of regenerative medicine. Our bones are alive, and they're always changing, like a house undergoing constant remodeling. Inside our bones, there are two types of cells that can handle this process. One of them breaks down bone, which is shown in blue, and the other is responsible for building up new bone, which is shown in tan. As we age, however, these builders will begin to slow down, while bone breakdown still continues. And over time, This can cause us to lose more bone than we make, causing them to become weak and fragile, which leads to the development of osteoporosis. And we can see this imbalance in action. When we look under a microscope at the femur of a healthy patient versus one with osteoporosis, we can see just how much bone is lost, creating these large pores that makes patients very vulnerable to fractures. This condition is also extremely common as we get older. After age 50, half of all women and a fourth of all men will have an osteoporosis-related fracture. And especially for women, in the 5 to 7 years after menopause, you can lose up to 20% of your bone mass. Current medications aim to slow bone breakdown, acting like a stoplight for these destructive cells. However, they can have really detrimental side effects over time. Because of this, new research is focused on ways to find ways that we can actively reverse the disease by building up new bone and targeting these cells. Stem cell therapies are an extremely promising avenue. A stem cell is a unique type of cell in the body that has the ability to become many different cell types. We can think of it like a kid deciding what they want to be when they grow up. When you're young, you can be anything. But as we get older, we start to specialize and we choose one career. Our stem cells do the same. And when it comes to making new bone, it's through this process of the stem cells differentiating and becoming bone cells. However, patients that have osteoporosis will often have fewer of these cells or less effective ones, making healing that much harder. Researchers at Cedars-Sinai are working with CIRM to develop a new treatment that can combine our stem cells with a hormone called parathyroid hormone, or PTH. This is already an approved treatment for severe osteoporosis. They're investigating to see how these two treatments can help patients heal from spinal fractures, which is one of the most common side effects of the condition. They found that in animal studies, rats that were treated with both the stem cells and the hormone healed much better than using just one of them alone. Mice that were treated with both showed up to 3 to 4 times more healing than mice that received only the hormone or only the stem cells. So rather than it being like 1 + 1 = 2, by combining these, you get almost like 1 + 1 = 3 or 4. The scientists hypothesized that this hormone might help the stem cells locate where the fracture is, allowing them to heal much faster. Right now, they're looking at using lower doses of this hormone to match what real patients would get in the clinic. What is my lab doing about osteoporosis? One of the greatest concerns, as you can see, is the risk of fracture, and my research looks at how we can heal from them faster. We can do this by turning our stem cells into bone cells, and we found a really surprising factor for transforming them. It's not a new drug or chemical, as we might expect, but it's something much more simple. Just how hard or soft a cell's environment is can actually tell stem cells to become bone. We discovered this by growing human stem cells in a gel, which we can control the properties of. So we can make this gel very hard or very soft. And then when we stain them to look for where the new bone cells are, we can see that in soft gels, very few of them become bone. And so anything that's gray has not become a bone, is a stem cell. And anything that's blue has become a bone cell. But when they're grown in a hard condition, almost all of them become bone. This huge difference is really exciting. And we're working right now to understand why this happens. One day, we hope to use this discovery to help patients improve recovery from fractures. How can you get involved? One of the biggest things in staying informed, just like attending presentations like the ones today. It's a great way to learn about the new research and the new breakthroughs being made. Most importantly, keep your friends and your family informed too. Every time I learn something about bone health, my mom is the first one to hear about it. You can also join support groups, such as the Bone Health and Osteoporosis Foundation. It's a great way to connect with other people who have osteoporosis and to learn from trusted resources. Lastly, you could also participate in clinical trials. Unfortunately, there are groups out there that try to prey on vulnerable patients by pretending to be trusted resources. To keep yourself and your loved ones safe, you can find reputable clinical trials on clinicaltrials.gov, and this will show you all of the validated and government verified clinical trials. I would like to thank CIRM and UCSB for supporting this research, and mentors Ian Taylor and Dr. Ryan Stowers, as well as everyone else involved. And finally, I would like to thank you, our audience that is here today. If you live in California, you are giving us your greatest support by considering CIRM when it's on the ballot again. And if you live outside of California, we're grateful for your support through staying informed and advocating for research. No matter where you are, through your support, we can create a better future for everyone. Thank you.
All right, Amy, thank you again for sharing. What an incredible presentation. Whoever is next, if you would like to go ahead and begin to present, feel free to do so.
Right, Karina, would you like to go?
Okay. Hello, everyone. How different would life feel if instead of the routine glucose monitoring, insulin injections, and overall dependence on insulin, diabetes was a thing of the past? That day free of the devices and needles may be sooner than you think with modern science. My name is Karina Chen, and I'm a graduate of UC Santa Barbara and a research intern for the California Institute for Regenerative Medicine. And today I will be talking to you all about recent cutting-edge treatments and research for type 1 diabetes. When we eat, we break down our food through the digestive system into microscopic fuel for our cells called glucose, which moves into our blood to reach all the cells in our body. And in order for the cells to absorb this glucose, your pancreas releases insulin. However, in type 1 diabetes, the pancreas is incapable of creating insulin. To combat this, there is the insulin pen, where people with type 1 diabetes deliver multiple daily injections to themselves. Another is the insulin pump with a glucose monitor, known as an artificial pancreas that continuously monitors blood sugar and releases insulin. These are several great day-to-day ways to deliver insulin, but they treat the symptoms rather than the cause. Today, clinical trials aim to refine treatments for diabetes and reduce type 1 diabetes overall reliance on synthetic insulin. One big researcher in diabetes research is Dr. Douglas Melton in Harvard University and Vertex Pharmaceuticals. In their clinical trial, they used stem cells, which are cells that are able to regenerate themselves and reprogram into almost all cells that you have in your body. But incredibly, scientists can make these cells from cells you already have. These are called induced pluripotent stem cells, where you start with a cell with a set identity, like your skin cells. And then you can make these, turn on certain genes to make induced pluripotent stem cells, and then make islet cells to make and release insulin for diabetes. In Dr. Douglas Melton's and Vertex Pharmaceuticals research, they make these induced pluripotent stem cells from specific patients' blood and then make hundreds of millions of functional islet cells, or the cells that release insulin in the pancreas, to supplement the dysfunctional pancreas in type 1 diabetes patients. With this patient-specific treatment from their own cells, it ultimately eliminated the need for donors and for immunosuppressants, some of the biggest hurdles for previous transplantation methods. Again, you can take cells and organs you don't need, like your appendix, create these induced pluripotent stem cells, and then into cells you do need, like islet cells. However, I study something more direct than stem cells, where I change the identity of existing cells into another one without that stem cell stage. This is called transdifferentiation, which is the direct reprogramming of cells. The ultimate goal of this method is to eliminate the possibility of rejection, the hurdles of stem cell derivation and culture, all without having to leave the body. Clinical trials are just one of the many things available to you that can be based on research just over here in Santa Barbara. Clinicaltrials.gov is a great website for reputable and fully funded clinical trials all around the country that you can be eligible for. I also recommend getting in touch with your local chapter of the American Diabetes Association with their emphasis on type 1 and type 2 diabetes. And for something in Southern California, the Samsung Diabetes Research Institute, where they have support groups and outreach events for individuals living with type 1 diabetes and caregivers impacted by it as well. I would like to thank the California Institute for Regenerative Medicine, which funds so many clinical trials, scientists, and trainees like me. I would also like to thank anyone who is a California resident who are directly influencing diabetes research and so many other breakthrough treatments with your vote for Prop 71 in 2004, and then again in 2020 with Prop 14. And thank you for all non-California residents as well. We're getting informed and learning about clinical trials and cutting-edge research. I'd also like to thank my mentors in CIRM, Rothman Lab, and UCSB for their support and guidance. Thank you.
Another incredible presentation. Thank you, Karina. Who would like to go next?
Yeah, we have 2 presentations left, and we'll have Eric go now.
Right. Can you guys see it? Okay, awesome. Hello everyone. Thanks all for all you being here. And today I'll be talking about my research and how some current reputable trials are in the field of cancer. Well, cancer changes lives. It affects not just the person diagnosed, but their family, friends, and their loved ones. I know this firsthand when my grandfather was diagnosed with cancer. My family felt overwhelmed and uncertain. But thanks to the advancement in immunotherapy, he's now living a full, healthy life. Well, that experience taught me the power of medicine, and it's also what drives my passion for cancer research. My name is Eric Howe, and I'm a recent graduate at UC Santa Barbara, and I'm a part of the California Institute for Regenerative Medicine undergraduate internship program. Well, today I want to take you on a journey through the cutting edge advancement in cancer treatments. I'll share how some groundbreaking new therapies are transforming the cancer treatments and how my research contributes to these advancements. So cancer arises when normal cells accumulate genetic mutations. Usually cells can detect these changes and either repair themselves or self-destruct to prevent harm. However, some mutations evade these defenses, causing uncontrolled growth, invasions, and even spreading to nearby organs. Well, cancer is particularly challenging because they're not made of just one, but different cell populations, each responding differently to treatment, so that one treatment that works for one may not work for the others. Well, additionally, tumors manipulate their environment, known as the tumor microenvironment, to sustain their growth and evade the immune system. Well, therefore, understanding this complexity and these cellular interactions is crucial for developing more effective treatments. So current cancer therapies, including local treatments like surgery and radiation, which target specific tumor sites, and systemic therapy, such as chemotherapy, hormone therapy, and target therapy, which acts throughout the body. While effective in many cases, these methods often fail to eliminate every cancer cell, allowing many tumors to return even stronger and more resistant. While an exciting clinical advancement recently addressing these challenges is something called a CAR T cell therapy, which is both a gene and cell therapy approach. In CAR T therapy, a patient's own immune cells are extracted from blood and genetically engineered in the lab to recognize protein that are only found on these tumors and thus destroy these cancer cells. Well, one example is a clinical trial conducted by UC San Francisco researchers targeting a specifically very aggressive brain tumor called the glioblastoma. They're currently in phase 1 and active recruiting. Well, this innovative therapy uses genetically engineered immune cells designed to recognize multiple targets within this glioblastoma or brain tumor, effectively attacking many cancer cell types and significantly reducing the risk of relapse seen with other traditional therapies. So now I'd like to talk about my research and how that plays a role in potentially finding new therapies for cancer treatments. So I'm studying how cancer cells are responding to stress. When cancer cells encounter stress, such as nutrient shortage or damage from treatments, they activate a mechanism that's something called integrated stress response to whether adapt or resist death, or even succumb to death with excessive stress. So my research focused on understanding exactly how cancer cells are leveraging this pathway to their advantage. Specifically, I'm asking how do these cancer cells reprogram this ISR or integrated stress response pathway to survive stress, and can we find a way to block this? Well, to investigate this, my project involves using a technology that enables us to activate these stress response with light in 60 different types of cancer cells. And after inducing these stress, I use artificial intelligence and advanced computational tools to analyze how these different cancer cells are responding to stress. This will eventually help me identify specific genetic patterns and vulnerability that could become therapeutic targets. The ultimate goal here is to disrupt the cancer cell's survival strategy, making them far more susceptible to treatments and improving patient outcomes. So as we discussed so far, there's exciting progress in cancer research, from advanced therapies to new insight into how cancer works. However, for patients and family facing a diagnosis, it can feel overwhelming. Well, fortunately, there are many trusted resources that can guide you through this journey. Well, the first, the California Institute for Regenerative Medicine, provides a vetted database of ongoing clinical trials across California, bringing cutting-edge treatments closer to patients. ClinicalTrials.gov, which is managed by the National Institute of Health, is also the world's largest registry of clinical studies, allowing searches by conditions, locations, or trial phases. And finally, the American Cancer Society offers a comprehensive support, including education, emotional support, and guidance for caregivers. I want to say this, that you're not alone, and these platforms are a great starting point to find reputable clinical trials, supportive care, and essential community connections. Well, before I wrap up, I'd like to take a moment to thank the incredible people who make this work possible. First, I want to acknowledge everyone in the Max Wilson's Lab at UC Santa Barbara. I've learned so much from this amazing team and their mentorship, support. I also want to extend my sincere thanks to the CIRM Compass program for their guidance and belief in me as a trainee. But most importantly, I want to thank the audience. This program is made possible by your investment in science, stem cell research through your support. Your support enables young scientists like myself to pursue these bold ideas, and I'm really deeply grateful for the opportunity to contribute to the future of cancer research. Thank you very much.
All right, thank you, Eric. That was also an incredible presentation. And then I guess we're handing it over to Evelyn now.
Yeah, I do see that there was a question from the audience saying, can you participate in a study if a disease runs in your family, but you don't have it yet? So oftentimes clinical trials will have inclusion and exclusion criteria for participants, meaning that you have to have certain traits. Like for example, my research, we're studying a blinding disease. So participants in our phase 1 trial that needed to show safety, we had to choose patients that were so far blind already that we couldn't hurt their sight anymore. The FDA would only allow us to use legally blind patients to show safety. They didn't want us to hurt them anymore. So we had to have patients that were legally blind for our phase. So we showed safety, and actually even in that we showed a little bit of efficacy where some of the blind patients actually recovered sight. So we're now moving on to a phase 2 trial, and that has an inclusion exclusion criteria where they can't be too blind, but they can't be too sighted either. There's like a range that we're looking for. And so all clinical trials will have a range. So if you're not exhibiting any symptoms of a disease, it may be hard to be included in a clinical trial, but it's really good for you to be aware of that and to keep aware of different opportunities and research going on for that, because research new breakthroughs are coming through like every month. and so the field is changing rapidly. And so stay on it, because therapies that are being made today, 3 years from now, they're going to be improved and they're going to be better. And so I would just keep in the loop about what's being made in science. Okay. All right, then we'll hand it over to Evelyn.
Hello, everyone. Thank you for being here on this Thursday morning. I want you to think about how your immune system helps you fight off colds and infections every day, quietly protecting you without you even realizing it. Now imagine if we could upgrade that same immune system to help fight something as serious as breast cancer. My name is Evelyn Sanchez, and I am a research intern in the Dr. Denise Montel Lab funded by CIRM. Breast cancer research is something very close to my heart because I've seen how it can affect my loved ones, And so today I want to share a little bit about a very aggressive type of breast cancer called triple negative breast cancer, or TNBC. It affects about 1 in 7 cancer patients and is harder to treat because it doesn't have the usual signs that doctors look for when choosing treatment. That means that the usual strong therapies, like a hormone therapy, won't work, and most people are left with surgery and chemotherapy and other treatments that can harm healthy cells. But there's hope. Scientists like me are working on new treatments that use a person's own immune system to fight cancer, kind of like turning your body into its own medicine. This is called personalized therapy, and we believe that it could help treat TNBC more safely and effectively in the future. Cell therapy uses a patient's own immune cells to fight cancer, like giving the body a natural boost. One type, called CAR T, trains these immune cells to find and attack cancer. At UCLA, a patient named Hirotaka Matsunaga, with a different type of cancer, a blood cancer, joined a CAR T trial after other treatments failed, and now he's been in remission for over 18 months. So far, 10 out of the 11 patients in this trial responded to treatment, and 8 had their tumors disappear completely. It's a promising step towards more effective and personalized care for blood cancer patients. But what about a solid tumor as aggressive as TNBC? Well, the therapy is not as strong. We can use a similar therapy, but with a stronger immune cell. This therapy is called CAR-M, and it can not only reach the tumors, but eat them too. In my lab, we've upgraded the CAR-M therapy with something called RAC2, making these cells much stronger at eating and destroying the tumor. We tested this in an experiment in a live baby chicken, still in its egg as our model. The results were clear. In box A, we see the tumor with no treatment. The tumor is in the center of the chicken embryo, and the red dotted line shows its outer perimeter. Box A shows the normal, untouched growth of a tumor. In box E, we see the tumor with the treatment. The red dotted circle still shows its outer perimeter, but the tumor has shrunk, making the red dotted circle smaller. The results are clear. The tumor shrunk with the treatment, meaning there is success in reducing tumor size, and in the future, we hope this therapy can help humans. This research is more than just about science. It's about people, and this fight is personal. That's why we need your voice, your support, and your partnership. If you're a patient, caregiver, or advocate, consider learning more about how to support cancer patients at the American Cancer Society, the Breast Cancer Resource Center here in California, and find legitimate clinical trials at clinicaltrials.gov, where new treatments are under tight regulation. Together, we are building a future where your immune system is your strongest ally, a future where hope looks like science and science looks like healing. I'd like to thank you all not only for being here today to educate yourself on innovative treatments like ours, but for supporting scientific research and being allies to our team. I'd also like to thank my lab for their incredible support, specifically my PI, Dr. Denise Montel, and my postdoc mentor, Dr. Abhinava Mishra. I'd like to thank CIRM for funding this research, and my CIRM mentors on campus, as well as UCSB. Thank you.
I think I could speak for everyone right now how impressive that was, what outstanding presentations from these brilliant young scientists who have given us lots to think about, lots of ways to get involved. And thank you also for communicating it in a way that we understood it. I think that part of the Compass mission is to get this research and get these studies and get this information out to the public so we can participate. And you all did such a good job of showing us ways to do that through a cross-section of diseases and lots of exciting applications of the existing science and your personal research. I'm excited and I'm encouraged and I'm so happy that we were able to gather you together today to share with our broader communities. Dr. Pennington, what great work you do.
Thank you. It's really the students. They're working so hard. I am really proud of all of them for what they've accomplished in their 2 years in the Compass program.
Well, a big part of what we're about at Lisa's Care Connection is empowering families on their journeys forward with Alzheimer's, dementia, and other chronic illnesses. So we know that we are asked most often about information about exactly what you all are doing. So for us to have these resources and to have this, I think, real message of hope. And I love, Dr. Pennington, that you said with clinical trials and other ways to participate, to stay on top of it and to know that it's so dynamic and it's changing so often that one door that's closed today doesn't mean that's going to be the answer 6 months, a year from now.
You're absolutely right.
So any questions, anything else we can do for you? You know how to get in touch with us. That's lisascareconnection.org. We would love to be of service if we can help you or your loved ones care for yourselves while you are caring for someone you love who has a diagnosis. We know how urgently important that work is, and we know that you are the ones who are providing the scaffolding that's holding up, I believe, our entire healthcare system. So we thank all the caregivers for that. And we thank you, scientists and thinkers, for moving us forward. Lots of progress.
Thank you. I
Thanks,
saw there was a
Daphne.
Q&A from the audience. We can address
Yes.
that now.
If you guys would, Brittany, if you would like to answer it, or if one of the students would like to answer it, the question is, are you a candidate for a clinical trial if you have 2 different types of diseases like cancer and dementia?
Yeah, I can go for that. But while I do, Evelyn, not to put you on the spot, but can you pull up your PowerPoint that walks us through the clinicaltrials.gov, that demonstration? So this is a great question. This is part of the inclusion exclusion criteria that we're talking about before. And certain trials will list certain diseases that if you have them, you'll be excluded from the trial. So for example, our eye therapy, if you have another instance of another eye disease, you wouldn't be able to participate in our clinical trial. So what Evelyn's going to do right now, she's just pulled up the clinicaltrials.gov website that each of the students is talking about. This is a database hosted by the NIH that shows all of the clinical trials, past, present, future, that are recruiting. And so do you want to just walk us from the very beginning of clinicaltrials.gov and how they can search for disease? And she'll use the triple negative breast cancer as her example, since that's her area of research. But this might be helpful because this will help you navigate this site and where you can find the inclusion and exclusion criteria for a trial that you might be interested in.
Yeah, of course. So I just went into the Google browser and I typed in clinicaltrials.gov. Once you're on this site, as you can see, it's in the NIH and you can put any condition as well as multiple conditions. I want to look at breast cancer. You can put a location, or if you're looking for a specific therapy, that could go in intervention treatment or just other terms and keywords. Once you click search, you'll see that for breast cancer in general, there are 15,390 studies. Here you can do, you can apply other filters. So I like to look at the active ones or the completed ones. They have more of a full story to them since they've been completed. And so we'll just go to this first one here. And here you can see the study details. So it's the study overview, contacts, and locations, but I like to look at the research review. That one will show us the trial description, which is really nice, recruitment information, which can include the inclusion and exclusion criteria. And if you just click on those subtabs, it'll drop you down. And here you can see like the title, the summary, description, and there are so many things that you can find on this site. It will take a really long time to go through all of them. But sometimes this trial specifically doesn't have results posted. You can look at the results of previous studies, and then you can also look at the record history. And so looking at the study details in the research review or the research view will give you almost everything you need to know about the trial. And then, like they said, they have a contact, so you can always reach out if you have any more questions. And then going back to search results, here that was just one trial, but there are 7,000 studies that are completed, and you can just scroll through and look for any that you might be interested in.
Great, thank you for that demo, Evelyn. One other thing I'd like to add, because for all of us, all the students here and myself, like it is personal, like the disease that we're focused on. Like for example, my disease, it's a macular degeneration. My grandma has this disease. So everything I've done in lab has had her in mind, like this therapy might go into Gami's eye. And so that's driven everything we've done in lab. In lab, you can have good or excellent quality, but there's another level called grandma quality, and that's the best kind, and that's what we strive to get. And so if my grandma was going on this site and she was thinking about participating in a clinical trial, questions that I would advise her to ask to consider participating in this are to ask, like, what was the preclinical data? Like, what were the side effects? The preclinical data is the animal models, just so you know, like what percentage of them improved, what percentage of them did not approve or had bad effects. And if it's a later phase clinical trial, like a phase 2 or phase 3, ask like, what was the safety data? Like, sure, how many patients were safe? And then were there any negative cases? And I would just ask for specific hard numbers, like what percentage of the patients showed improvement, had different effects. I think that was what I would advise my grandma to ask the clinical coordinator as you're considering being recruited for a clinical trial. But clinical trials are very important for bringing a therapy from bench to bedside. And that is an incredible, powerful role that you can play in helping us bring these therapies to the bedside. So thank you for considering. One other question is if there's a placebo group in your clinical trial, there might be a chance that you are assigned as a placebo group, meaning that you didn't get the active treatment. Ask if after the trial, would you have an opportunity of receiving the actual treatment? That could be an option for some clinical trials. So that'd be another question to ask. But it's important that you stay informed of all the possibilities so you can assess the risks yourself for whatever is right for you.
Those are really great tips, great advice. Thank you for your questions. Thank you all for your participation today. Certainly feel free to follow up with CIRM, with all of their many programs and all the ways that they are making treatments and therapies more available into the lives of families. This whole thing started because in our state, we decided we didn't want to wait and we wanted to move more aggressively. And so it's a great example of all of us as voters really making our voices heard that this is urgently important to us. So staying involved in this agency, which is a public agency, you own it, right? You all own it and participate in it and can attend the meetings and can have access to all of it. So that's just really super cool. So thanks to CIRM, thanks to all of you amazing young scientists. We're counting on you. Dr. Pennington, this was lovely. And Daphne, unless we have anything else, we'll say thank you and everyone have a great day.
There is one last question
Oh,
that
good.
maybe answer before we head out. But the question is, with research in multiple areas being defunded by new policies, how can we help restore funding for the important research and work that is needed to progress wellness and solving diseases for our future?
That's an excellent question. One of the benefits of being funded by CIRM, the California Institute for Regenerative Medicine, is it's not federal, it's state funded. And so our funding hasn't been affected by the federal policies that have come down. So what you can do as a citizen, no matter what state you're in, is write your representative and advocate for state-funded research for stem cell therapies and gene therapies. You can make your own state version of California Institute for Regenerative Medicine, like insert your state name, Institute for Regenerative Medicine. And then also write your federal representatives to say, among the cuts, don't cut this, because this is essential for our progress.
And that really matters. That stuff really counts. I know sometimes we think, oh, it's just one email or one phone call. That is the gauge by which they determine levels of interest and that directs future behaviors. So that's a really big deal. So I'm glad we got to that one.
Me too. Writing and also showing up at the polls to vote for these initiatives. The California Institute for Regenerative Medicine initiative barely passed in California this past time. And I think that's because to address that, the scientists are trying to do a better job now at communicating to the public. This is how we are being stewards of the state funds. We are working, blood, sweat, and tears are going into our research here, trying to get these therapies out because we want to help people. And so we're trying to do a better job at communicating what we're doing with this funds. And so showing up at the ballot also in California would really help keep these programs active.
Thank you for touching on that. It is so vital and so important to the scientific research and progressing healthcare and medicine as where we see it today versus what it could be. So thank you for touching on that and voicing how important it is to show up to the polls, talk to your representatives, and advocate for these type of policies and fundings to continue to be in place, if not expanded. Before I pass over to Lisa, if there are any questions, you can feel free to email our info@Lisa's Care Connection email with any questions that you may have, or you can contact myself directly. My name is Daphne, spelled Daphne, at Lisa's Care Connection as well. If you have any further questions, or if you're needing any counseling or care consultations regarding your loved one or yourself, please feel free to reach out. And then I will go ahead, excuse me, I will go ahead and pass over to you, Lisa, to give final thoughts and wrap up for us.
I have shared my final thoughts, and I have failed to plug again our senior prom, as I did at the beginning. If you are in California, please join us September 18th. This is a really beautiful night celebrating the relationships between our seniors and all the other generations. We get together and dance. We crown a king and queen at the end of the night. But if you can't, please do sponsor a senior. For $75, you can send someone to the prom. And this is a really important way for us to destigmatize aging and to encourage the socialization that happens and the brain health that occurs when people get together. We're hardwired to do that. So a great chance for you to say, yeah, maybe somebody's never, and you'll be surprised at how many seniors say they've never put on a corsage, they've never been out at the prom, they've never had that experience, and they deserve it. So that's lisascareconnection.org. Thank you again to these great young people. You did an amazing job, and have a great rest of the day. Appreciate everybody. Bye for now.
Thank you all again for your time, and appreciate everything that you guys have done for advancing the research for each of your topics. Thank you again.